Hello everyone, my name is Chitipat Wongwat and today I will presenting you on the topic of the gasification of engine. As a part of combustion and emission control course, I will focusing on how we can convert the biomass into the clean energy and how we control the emission from this process. So let's dive deeper into what is the gasification engine actually is. It is not just an engine, but is an entire energy conversion system. The primary goal is to take solid organic matter, which we call biomass, and transform it into high value gases. Fuel is known as the sign gas. This is achieved through a thermochemical process that happens inside a reactor called a gasifier, unlike the incineration, which simply burns waste to produce the heat. Gasification breaks down the chemical bond of the biomass to create mixture of the carbon monoxide and the hydrogen. To make this work is an internal combustion engine. The system must have four critical stage. First is the gasifier, where the solid to gas conversion happens. Second one is cleaning system. This is vital because raw sign gas contains tar and dust that can destroy the engine valves. Third, the air gas mixers which function like high precision carburetor to ensure the engine gets the right fuel density. And the last one is the ICE unit, the typically a modified spark ignition engine that converts the chemical energy into the mechanical energy power for the electricity or torque. So now let's connect this to the our combustion principles. The core of gasification is partial oxidation in a standard engine. So we aiming for a stoichiometric ratio or the excess air, but in a gasifier, we intentionally starve the fuel of oxygen. We keep the equivalence ratio significantly low to ensure that we don't reach the full of the combustion. So we can build this as a two-stage combustion process. Stage one is to occurs in the gasifier where we provide just enough heat to drive endothermic reaction that can produce CO and H2. The stage 2 happens inside the engine cylinder where the sign gas is finally mixed with the secondary air and ignites to complete the oxidation process. This stage approach allows us to manage the flame temperature and chemistry much more precisely than burning wood in furnace. It is the perfect example of how we manipulate combustion kinetics to produce useful energy instead of just wasting heat. And this slide is covers the most important part of our course, the emission control. When we burn the biomass directly, we got a huge amount of smoke, soot, and toxic gases. However, with the gasification engine, we have a unique advantage. It's pre-combustion cleaning. Before the gas ever reaches to the engine, we put it through the cyclones and the scrubbers to remove the particulate matters, or you call it PM, and the tar. If we don't control this, they will be cause heavy deposit and engine fail. Inside the engine, our main concern is nitrogen oxide because sign gas burn differently than gasoline. We have to carefully control the air fuel ratio and spark timing to keep the peak combustion temperature in check. By we optimizing these parameters, we can achieve emission that are significantly lower than the traditional solid fuel system, making it much greener way to use biomass for power. Now you might asking why go through all the trouble of gasifying biomass instead of just burning it or using the solar power. So the answer is in the sustainability and the reliability. First, we are talking about the waste to energy. In many agricultural areas, biomass waste is often burned in the open fields causing the massive air pollution. By using the gasification engine, we turn that waste into the renewable energy source. Second, this system is carbon neutral or the CO2 release during the combustion is the same amount that the plants absorb during their growth, making it a closed loop that doesn't contribute to global warming. And third, last one, unlike the solar or wind power, which are the intermittent, and a gasification engine provides the base load power. As long as we have the stored biomass, we can generate electricity for 24 hours a day, regardless of the weather. It offers highly thermal efficiency and gives us the control way to manage energy production. The and that is far superior to the traditional solid fuel combustion. To conclude my presentation, the gasification engine is represent a vital intersection between the mechanical engineering and the environment science. Through the principles of the combustion and emission control, we have shown that it is possible to use solid waste fuel in a way that is both efficient and clean. We discussed how we manage the equivalence ratio to produce syngas and how we use pre-combustion cleaning to ensure our emission meet environment standards. This technology is sustainable solution that addresses two problems at once: waste management and the need for clean, reliable energy. It is a key area of study that will help us move towards a more sustainable, the greener future. Thank you everyone for your attention.